The following demonstration will show how the network sniffers Wireshark and TCP dump can capture network traffic that flows laterally on a network. The goal of this demonstration is to illustrate how a rogue network administrator can gather network data with a packet sniffer. The diagram shows four systems: server A with an IP address of 192.168.100.5, host B with an IP address of .99, host C with an IP address of .10, and host D with an IP address of .15. One network backbone was used to create the internal network infrastructure. All four systems are on the same network segment, and the network interface card of host B is set to promiscuous mode. The network is configured with Oracle's VirtualBox. Systems A, B, and C are configured with the Linux Ubuntu 15.10 operating system. System D is a Microsoft Windows 7 OS. In the demonstration, host C will connect to an HTTP server that is being hosted on server A and pull a web page. Host B will use TCP dump with a custom Berkeley packet filter to capture the web traffic. In the second demonstration, host D will execute a telnet connection to server A. Host B will use a second custom Berkeley packet filter to capture the specified network traffic involved with the telnet session. We will grab this traffic and analyze it for the clear text password. Server A has an Apache web server configured at 192.168.100.5 and is listening on port 80 for web traffic. We will begin by executing the following command on host B. This command will grab all port 80 traffic that originates from host D. So we'll go over to host B and execute the command. And as you can see, it's listening on its interface for all the traffic that we've specified in the TCP dump. Next, we'll go over to the Win7 system and launch a browser and browse to the website that we set up on server A. As you can see, the TCP dump is capturing all the traffic that's destined to the web server on .5, and it originated from .15. You can also see in the TCP dump the GET requests that were performed to pull the web page. This shows how all browsing activity can easily be captured for later analysis by any rogue administrator. Next, the rogue administrator wants to grab all telnet traffic that originates from the Windows 7 box that is destined to the server. This time, the rogue administrator will grab all TCP port 23 traffic, which is telnet, that originates from host D, and save it to a file called telnet.pcap for later analysis. So he executes the command, and like before, we're listening on the interface for all telnet traffic, and we're going to write it to a file called telnet.pcap. So the user on host D decides to telnet into server A. So we'll connect to the server. We will log in as the user Steve and enter the password GoHawks. Do a hostname command. We are on server A. We'll exit out. Next, we will stop our packet capture. This will write everything that we've captured to the file that we specified, which is the telnet.pcap file. Next, we will launch Wireshark to analyze the PCAP. We'll open the file. We'll follow the stream to show that in fact that Steve's password was captured in clear text, as expected with the Telnet protocol. When it comes to sniffing network traffic, Wireshark and TCP-dump are powerful tools. This demonstration showed how the east-west data can be captured on a network, written to a file, and analyzed at a later time. A rogue network administrator can use these tools to conduct intelligence gathering or corporate espionage. Consequently, it is critical that policies are implemented to segment network data by using virtual local area networks, disabling the use of unencrypted protocols such as Telnet, and dividing network administrator roles into smaller segments to help mitigate this risk. Thank you.